What's going on, guys? Mr. Myers here with another math lesson. And today we're going to work in IXL again. So go ahead and watch this video, what we're doing, and uh, and you can try it yourself here. So remember, when you go to IXL, log in up here. We're going to learning, math, algebra 1. Today we're going to do skill EE7, which can be a little tricky. So I'm going to demonstrate some for you here. And so there's only one skill to do today. It's skill EE7, divide radical expressions. And we'll do some examples here. So let's look at this example right here. 2 over -4 plus the square root of 3. When you do this, we want to simplify this, and the most important thing we want to do is we want to make sure there's no square roots in the denominator, in the bottom of it. So we're going to use kind of the idea of multiplying a fraction by the top and the bottom. For example, remember, if you have, like, say, 1/4, you can multiply, if you multiply the bottom by anything you want, as long as you do it to the top, you'll have an equal fraction. So now we get 3/12, which is equal to 1/4 in this example. We're going to use that idea. In this type of problem, what we're going to multiply the top and the bottom both by is the conjugate of this. Conjugate is basically a fancy word for saying change this addition to the opposite sign. If it was since it's an addition, we're going to change it to a subtraction. So that's going to be -4 minus root of 3. And we got to make sure that we do that to the top and the bottom both to keep it an equal fraction. You might be wondering why we're doing that. You're going to see in a minute why we do that. That's going to get rid of the square roots. It's basically going to make it so there's no square roots in it after we do that. So this that we just used there's a vocab word today that is called the conjugate of this. It's basically two terms. You change the addition to the opposite sign to a subtraction. Okay, so when we do this, when we do the bottom, this is a binomial times a binomial. That's two terms by two terms. And so as we know, when we do two terms by two terms, a good way to do that is to do a 2 by 2 grid. And I'm just going to change this instead of a subtraction. I think it'll make more sense if I change it to plus negative and put a 1 in front of it. -1 times that, it's the same thing, we know that, but that should make it a little bit less confusing, hopefully, for you guys and keep it a little bit cleaner here. So we're doing this multiplication right now on the bottom. -4 plus root 3 times -4 minus root 3, but I'm changing it to -1 root 3 just to keep it a little bit clean here. So here's what happens, and you won't have to do this with all these because you're going to pick up the pattern, but I'll show it for the first couple as far as drawing this rectangle here. You won't have to always do this. This corner is -4 times -4, that's positive 16. Over here, this is -4 times the root of 3. Down here, this is negative times negative, actually makes positive 4 root 3. And down in this corner, we have the root 3 times root 3, which is just 3. And then this negative times positive, so that's -3. Okay, you can see something cool happens here. When we add up these four spaces inside here, these four parts, these are like terms. They're both root 3. So -4 root 3 and positive 4 root 3, they just add up to 0, which cancel each other out, you could say. So we have basically just 16 minus 3, or 16 plus -3, which is 13. So the bottom of this, after we multiply it, is 13. The top, this is now one term times two terms, so we're going to distribute here. So now we have 2 times -4, which is -8, plus, and then 2 times -1 root 3, that'd be -2 root 3. So we have -8 plus -2 root 3 over 13. This you could write as a subtraction right here, this negative. Okay, one more thing to be careful of. It's not going to happen on this one, but sometimes the fraction can be reduced. If these all had a common factor, for example, if this was an even number down here, let's just say this was a 10, we'd be able to reduce a 2 out of the top and the bottom. And when we reduce a 2 out of the top and the bottom, we would divide both these terms by 2. It's like a distributive property. But we don't have to do that on this one. There's no common factors. Let me type it in. Now, when you guys type these in, this is a fraction, so you got to make sure you do the fraction thing. And we go -8 plus negative, or we'll just say minus 2 root 3 all over 13. Hopefully this is right. Let's see. Yep, we got it right. So remember, just like the other days, we're working for a SMART score of 50. Right now we've got 10. Once you get to 50, you are done for the day with your math. So let's try another one here, and we'll just do a couple more. Hopefully we'll get one where we have to simplify it at the end. Okay, this will go faster this time because we should be a little better at it now. What we're going to do to rationalize that denominator is multiplied by the conjugate. So that's going to be 6 plus root 3. And make sure you do it to the top and the bottom both. And when you do this 6 plus root 3 times 6 minus 3, I'll draw this one out one more time, a 2 by 2 grid. And maybe the next one we'll do in our head here. So we don't have to do this every time. We have 6 minus root 3. And if you want to put a negative 1 in front of that, that's fine. Sometimes I do that just to keep it a little bit cleaner here. And 6 plus root 3. So we got 6 times 6, 36. We have negative 6 root 3 in this corner. We have positive 6 root 3 in this corner. And here, root 3 times root 3. Actually, that's negative root 3, right? So that makes negative 3. And those two corners add up to 0. So we just have 36 minus 3, which is 33 in the denominator. So we've rationalized the denominator, which means basically we don't have any more square roots in the denominator. It's a rational number. And on the top, we're going to distribute negative 4 times 6 is negative 24, plus, and then negative 4 times the root of 3 is just negative 4 times the root of 3. We'll leave it just like that. Let's type this one in. Negative 20, oops, I got to make sure we do it, make sure you do a fraction here. Negative 24 plus negative 4 root 3 all over 33. Submit. There we go. Right. Let's try this one. The conjugate of the bottom is going to be negative 6 plus root 3. And we do that to the top also, negative 6 plus root 3. This one now, let's not draw the rectangle. We know that the upper left corner is going to be negative 6 times negative 6. That's going to be 36. And the other two corners, the upper right and the lower left, will cancel each other out when we do the conjugate. And the bottom is going to be negative root 3 times positive root 3. That's negative 3. So that actually makes 33 on the bottom again here. And then we distribute the top. We have negative 30 plus 5 root 3. Again, we're going to look for anything that can be simplified in this one, and it can't. Hopefully soon they'll give us one that can be simplified. So we have negative 30. Negative 30 plus 5 times the root of 3 all over 33. You guys are going to look really smart when you're doing these because I'm sure your parents won't remember how to do this stuff, huh? Okay, let's try another one. What's my SMART score here, I wonder? It's got to be getting up there. We'll see in a second. We're going to multiply by the conjugate. The conjugate of negative 3 plus root 2 would be negative 3 minus root 2. And do that to the top also. When we do the bottom here, you can picture the upper left corner is going to be negative 3 times negative 3. That's 9. The other two corners are going to cancel each other out, and we're going to have negative root of 2 times positive root of 2, which is just minus 2 or plus negative 2 as the bottom. So we got a 7 down there. The top, we distribute 6 times negative 3, negative 18, plus, and then 6 times the root of 2, which is just negative. Look, there's a subtraction there. We got to be careful. Negative 6 root 2. We get going kind of fast here. So that bottom is 7, right? 7, and we got 18 plus negative 6 root 2 over 7. All right, 18. Anyways, you can put that in. One thing I want to do before I close out the video is talk about when they need to be simplified. Here's an example of one that would need to be simplified further. Let's just say you end with this. 10 plus 2 root 3 all over 12. This is not quite in simplest form right now because the top and the bottom of this can both be divided by 2. It's kind of like, for example, if you have the fraction 2/8, that's not in simplest form because the top and the bottom can both be divided by 2, and it goes down to 1/4. So in this one, when we divide the top and the bottom by 2, you get 6 on the bottom. Just make sure you distribute a divided by 2 to both terms here. Remember, when we divide by 2, we have to, it's like a distributive property. So that's going to be 5 plus, and then this 2 divided by 2 just makes 1 root 3, or just root 3 all over 6. So if you get one like that, make sure you simplify it so that you get it correct when you submit it into IXL. Here's another one, 3 plus 6 root 5 all over 9. These are all divisible by 3, right? So we can divide by 3 to the top and the bottom, and that would come out to be 1 plus 2 root 5 all over 3. All right, good luck. Shoot me an email if you have any questions, and we'll talk to you soon.